Welcome to the Deep Dive. Today we have a genuinely fascinating stack of technical notes and press releases that, it might actually answer a question the tech world has been struggling with for years.
Yeah, it's a big one.
Right. How do we meaningfully change the way we absorb complex information? I want you to think about your own habits when you're trying to learn a dense new topic or maybe prep for a highly technical meeting.
Oh, we all know the drill.
Exactly. You are probably staring at a flat screen, scrolling through a 40-page PDF, or watching a two-dimensional video. It's passive, it's flat, and let's be completely honest, it is incredibly easy to lose focus.
It's basically an invitation to zone out.
Totally. But today, our mission is to explore a newly announced platform called EON Sentient Worlds. It's created by EON AI Ventures.
Right.
And we're going to figure out how this platform is taking massive cutting-edge AI models, combining them with augmented reality, and quite literally bringing knowledge off the screen and into your physical space.
It represents a profound shift in interface design. We are looking at a transition from a paradigm where you have to go to the information, seeking it out on a screen, to a model where the information physically surrounds you.
Which sounds like science fiction.
It does, but when you dig into the architecture of EON Sentient Worlds, it becomes apparent that this is not a lightweight chatbot. It's not a simple virtual reality gimmick either. The developers have assembled an incredibly heavy-hitting multimodal technology stack.
Okay, let's unpack this, because throwing all those massive AI models into a blender sounds impressive on a press release. But we need to look at what that multi-model approach actually achieves.
Right. They aren't just relying on a single provider here. They are integrating Google's Genie 3, OpenAI's GPT-4o, HeyGen, and Gemini 2.0 Flash.
That is a serious lineup.
It is. And they are layering these foundational models directly on top of EON Reality's 25 years of experience in the spatial computing and immersive technology sector.
Wow, 25 years.
Yeah, they have a quarter-century of infrastructure built for XR, and they are now supercharging it with the absolute most advanced generative AI available.
So they're using HeyGen for the visual generation of avatars, Gemini 2.0 Flash for rapid context retrieval, and Genie 3 as a foundational 3D model. It is a highly orchestrated system.
Highly orchestrated. And the core mechanism driving all of this is something they call the Wonder Engine.
Yes, I was looking at that. The technical documentation describes this as an AI-powered content engine designed to take dry, traditional educational topics like dense science, historical events, complex technical engineering, and transform them into cinematic experiences.
Which is huge for content creation.
Right. I keep thinking about those late nights trying to parse through dense AWS white papers or highly technical fluid dynamics reports. You're fighting heavy eyelids trying to hold the entire architecture in your head.
It's exhausting cognitive work.
It really is. The Wonder Engine is designed to take that exact same topic and dynamically produce it into a cinematic, spatially aware presentation. You're watching a movie instead of reading a manual.
The Wonder Engine is essentially automating the heaviest lift in the immersive education space. Historically, if an enterprise or a university wanted a 3D interactive module on how a commercial jet engine functions,
They'd need an entire studio.
Exactly. A team of developers, 3D modelers, and animators would have to spend months and tens of thousands of dollars building it from scratch.
Just for one lesson.
Right. Now, this orchestrated AI system is generating the narration, the visual assets, and the environments dynamically. But a cinematic video, no matter how quickly it is generated, is still fundamentally passive.
You're still just watching.
You're still just watching. The critical leap in this platform happens immediately after that video plays.
And that brings us to one of the most compelling features in these sources, which is the AI mentor. They call it Brainy.
Brainy, yeah.
This is where that GPT-4o integration comes into play. Brainy is not a text box at the bottom of the screen. It is a voice-enabled, context-aware AI entity that steps in the moment your cinematic overview finishes.
It's seamless.
You don't type at it. You speak to it. You ask it questions about the material you just watched, and it explains concepts, adapting to your specific line of inquiry in real time.
What's fascinating here is the pedagogical shift this creates. Brainy is not just retrieving facts from a database. It is maintaining a dynamic, highly contextualized dialogue.
Like a real neuter.
Precisely. For decades, both formal education and corporate training have been bottlenecked by passive consumption models. You sit, you read or watch, and the system just hopes you retain the information.
Fingers crossed.
Right. But by introducing an AI mentor immediately following a visual primer, the platform forces a shift toward active, dialogue-driven learning. If you're struggling to understand the specific pressure differentials in that jet engine module, you just stop the lesson.
And yes, Brainy.
You ask Brainy to explain it using a different analogy. You interrogate the material. It's the Socratic method of learning, which is historically one of the most effective ways to build deep comprehension.
But now it's being scaled infinitely.
Infinite scale. You have a one-on-one tutor with near limitless domain knowledge, anchored entirely to the context of the visual lesson you just experienced.
I am looking at the scope of this, though. Dynamically generating 3D cinematic videos, running continuous GPT-4o voice interactions, and eventually pushing all of this into augmented reality. And I have to play devil's advocate regarding the infrastructure.
The compute costs.
Yes. Rendering dynamic 3D environments and maintaining low-latency voice AI is incredibly compute-heavy. The server costs for a platform doing this at scale would normally be astronomical.
No, it would burn through venture capital in a week.
Right. Yet the pricing tiers outlined in the press release start at $9.99 a month for individual users. How on earth is EON AI Ventures keeping their overhead low enough to offer a Spotify-level price point while running this kind of heavy artillery?
That is the exact engineering hurdle that has killed several previous iterations of spatial computing.
Really?
Oh, yeah. Companies try to render fully interactive, high-fidelity 3D assets for every single user interaction. The compute costs skyrocket while the user's mobile battery drains in 20 minutes.
So how did EON solve it?
EON's solution to this is structural, and it's arguably the most elegant piece of engineering in the entire platform.
Here's where it gets really interesting. EON Sentient Worlds has built a framework they call the Progressive Immersion Ladder.
The latter.
It's essentially a progressive rendering pipeline for human attention. Think of it like dipping your toes in a pool to check the temperature before you decide to throw on your scuba gear and dive to the bottom.
That is a great way to look at it.
They do not load the heavy, expensive 3D assets or activate the complex spatial tracking until you, the user, have proven you are actually engaged with the base material. They break the learning process into 4 distinct steps,
aiding the heavier compute features behind active participation. It operates as both a cognitive framework for the user and a resource management protocol for the servers.
Let's map out how those 4 steps actually distribute the computing load, because it's a brilliant balance of user experience and cost efficiency. I can take the first 2 steps, which are the lightweight entry points.
Go for it.
Step 1 is the pre-rendered video. This is just a 60-second cinematic overview of the topic. It requires very little compute power to stream. It serves as the hook to see if you even care about this subject.
Testing the waters.
Exactly. If you're interested, you move to step 2, the AI conversation. This activates Brainy. You're still in a relatively low compute environment relying on voice and text protocols. You contextualize the information, ask your initial questions, and build a foundational understanding.
And for a lot of casual queries, a user might stop right there.
Yeah, the system provided the answer without ever needing to render a single polygon.
But if you require a deeper spatial understanding of the topic, you initiate step 3, which is 3D exploration.
This is where things get heavy.
Right. This is the threshold where the platform allocates significant resources. The standard 2-dimensional video frame breaks open, and the lesson becomes a fully walkable, interactive 3D environment right on your screen.
So you can manipulate the objects?
You rotate them, explore the spatial relationships. The cognitive load shifts entirely here. You're no longer just processing language. You are engaging your spatial awareness, which activates completely different neural pathways.
And the final rung of the ladder is step 4, AR on your phone.
This is the peak.
This is where the platform taps into the LiDAR scanners built into modern mobile devices. The notes detail how this projects the 3D environments directly into your physical space. You don't need a bulky, expensive headset.
Just the phone in your pocket.
The examples they provide are striking. If you are studying meteorology, you can use your phone to anchor a swirling, active 3D thunderstorm right in the middle of your living room.
Incredible.
Or if you're an anatomy student, you can project a beating human heart onto your kitchen table. You can physically walk around it, lean in, and inspect the ventricles. You are fully immersed in the data.
By designing the platform this way, using that ladder, EON ensures they're reserving the heavy artillery, the massive rendering costs, and AR anchoring only for the users who have actively climbed the ladder.
That makes total sense.
If you just watch the 60-second video and close the app, the system didn't waste a massive amount of server power rendering a 3D thunderstorm you were never going to look at.
It's highly pragmatic.
It's the only way to scale immersive tech globally, bypassing the hardware limitations that plagued early AR headsets like Magic Leap or Google Glass.
That structural efficiency completely explains the accessibility of the platform. Because they aren't bleeding server costs on unengaged users, they can deploy this at an enterprise and institutional scale with minimal friction. We mentioned the $99 monthly tier for individuals, but the institutional pricing is where you see the real strategy. It is $500 per classroom, and an entire school can deploy the platform starting at $5,000 annually.
Which is very accessible for a district.
And because it runs through modern mobile devices and standard web interfaces, institutions don't need to secure capital for thousands of high-end VR headsets.
The hardware-agnostic approach is crucial, but honestly, the software integration is what actually gets a tool adopted by massive bureaucracies.
Yeah, the back-end stuff.
Exactly. For anyone who has ever had to implement a new technology at a university or a massive corporation, you know that a flashy interface is absolutely meaningless if it doesn't plug into the existing administrative backend.
It just becomes an expensive toy.
Exactly. The documentation highlights that EON Sentient Worlds includes dedicated teacher dashboards, detailed progress analytics to track where a student or employee might be falling behind, and the ability to assign specific immersive modules natively.
The sources also emphasize SCORM and LTI compliance.
A huge deal in that space.
For those who are fortunate enough to avoid educational software acronyms, this essentially solves the last-mile problem of EdTech. SCORM and LTI compliance means this platform can talk seamlessly to the learning management systems that schools and corporations already rely on.
Like Canvas or Blackboard.
Exactly, or corporate HR portals.
Yeah.
Educators and managers do not have to overhaul their entire grading, tracking, and certification systems just to utilize the new augmented reality features. The data flows right into their existing workflows.
If we connect this to the bigger picture, the emphasis on rigorous institutional integration points directly to the core philosophy of the parent company, EON AI Ventures.
How so?
Well, they operate two distinct but complementary platform businesses. The first is the enterprise AI platform, which focuses heavily on operational intelligence and workforce performance.
Got it.
The second is the virtual campus, or virtual campus, which manages scalable training, certification, and knowledge transfer for academic institutions and governments. Their entire architecture is built around environments where outcomes are strictly measured.
So the notes make a very sharp distinction here between what EON is building and the broader landscape of generic AI tools.
They do.
They are very clear that they're not just building another consumer-grade wrapper for OpenAI.
It's a critical distinction to make in the current tech ecosystem. Your standard, generic AI, the consumer chatbots and image generators most people use daily, might deliver an output that is 80% accurate.
Which is fine for a lot of things.
Right. For a casual user summarizing a long article, writing a marketing email, or generating a fun avatar, 80% quality is perfectly acceptable. The stakes are incredibly low.
But EON AI Ventures is explicitly targeting high-stakes operations.
They argue that in environments where precision is non-negotiable, whether that involves certifying a medical professional for surgery, training an aerospace engineer on turbine maintenance, or deploying workforce solutions for a national government, 80% accuracy is a catastrophic failure.
You can't have a hallucination there.
No. High-stakes operations require 100% operational precision.
It is the difference between asking an AI to generate a recipe for a dinner party and asking an AI to walk you through the repair sequence for a high-voltage municipal power grid.
Precisely.
You can tolerate a hallucination if your soup has too much salt. You cannot tolerate a hallucination when you're dealing with critical civic infrastructure.
Exactly right.
Because EON has a 25-year legacy in building XR solutions specifically for enterprise transformation. They have designed their multi-model architecture to prioritize that rigorous operational reliability over simple parlor tricks.
They are anchoring the generative AI to strict, verifiable knowledge bases.
That foundation of reliability is what makes the Wonder Engine and the AI Mentor actually viable for institutional use.
If the underlying data wasn't locked down and precise, a university would never allow students to engage with it, no matter how beautiful the 3D thunderstorms looked.
The visual immersion is just the delivery mechanism for highly validated intelligence.
Exactly.
So what does this all mean? We have covered a massive amount of ground here. From the orchestration of Gemini, Genie 3, and GPT-4o to the progressive rendering pipeline of the immersion ladder, all the way to SCORM compliance in enterprise deployment.
It's a massive ecosystem.
It really is. I want to pull a quote directly from the technical notes. It's from Dan Lajerskar, the chairman of EON AI Ventures, and I think it synthesizes the ultimate objective of this entire technology stack.
What did he say?
He stated, "The launch of EON Sentient Worlds is a pivotal moment in the evolution of immersive technology. We're replacing scrolling with exploring, creating a new standard for curiosity-driven engagement. Every step on this journey is designed to inspire learning and wonder on a global scale."
Replacing scrolling with exploring.
Replacing scrolling with exploring, that is a fundamental reframing of how we interact with the digital world.
It captures the exact utility of what we're analyzing today. This technology directly addresses a profound friction point for anyone trying to stay well-informed.
The information overload.
Yes, you want to gain knowledge quickly and you want to understand complex systems thoroughly, but the modern digital landscape just bombards you. Traditional text and flat media often exacerbate that overwhelm because they force your brain to do the heavy lifting of visualizing abstract, multidimensional concepts.
Which is exhausting.
By offloading that visualization process to the Wonder Engine and by allowing you to converse naturally with an entity like Brainy, the technology systematically removes the cognitive friction.
It makes acquiring deep, highly technical knowledge feel as intuitive as walking around a room and having a conversation.
You're no longer fighting the format of the information. The format is dynamically adapting to your specific curiosity and your physical environment.
It brings a sense of agency back to the learning process, which is something that traditional passive media has largely stripped away.
This raises an important question, though, something we need to carefully consider as spatial computing and multimodal AI scale over the next decade.
Okay.
If our daily consumption of knowledge transitions away from reading flat, two-dimensional text on a screen and moves toward physically walking through 3D simulations in our living rooms, how will this reliance on spatial memory change the physical structure of human brains?
Oh, wow.
If the next generation's fundamental perception of reality is one where digital knowledge is inherently volumetric, spatially anchored, and conversational, how does that alter the long-term evolution of human cognition and our baseline relationship with the physical world?
If we stop reading to learn and start walking to learn, our brains are going to map information in a completely unprecedented way. We might literally reshape our own neural pathways just by changing the dimensions of our digital textbooks.
It is a massive paradigm shift to think about.
It really is. Thank you so much for joining us on this deep dive today. Take some time to think about your own learning habits, how much cognitive energy you spend just trying to visualize complex ideas, and how a spatially aware AI mentor might completely change that process for you in the near future. Keep asking hard questions, keep seeking out new perspectives, and above all, stay curious.